So, if you're working with Amazon DynamoDB, you know just how powerful it is. But let's be real, you also know that sometimes weird stuff happens. Today, we're going to open up a little field guide and go hunting for the most common and, let's face it, the most stressful DynamoDB gremlins.
Okay, picture this. You get the alert. PagerDuty is just screaming at you. Users are hitting you up on social media complaining your application is totally down. And suddenly, all eyes turn to the database. It's that heart-in-your-throat moment every developer knows all too well. Is DynamoDB the culprit? And if it is, what on earth do you do next?
Well, we're going to treat these problems like what they are. Mischievous little gremlins, just wreaking havoc on your system. So in this explainer, we are officially going gremlin hunting. We're going to tackle 3 of the most common issues that you're going to run into out in the wild.
First up, we've got the internal server error, which we're going to call the ghost, because it just appears and disappears mysteriously. Then there's the lag, those awful, unpredictable latency spikes that just drive your users crazy. And finally, we've got the most complex of them all, throttling. We'll call this one the maze, because wow, navigating it can be really, really tricky.
All right, let's start with our first gremlin, the ghost. Seeing an internal server error can be super alarming, right? But in a massive distributed system like DynamoDB, they aren't always a sign of total disaster. A lot of the time, they're just transient. The real trick is knowing when it's okay to relax and when you need to spring into action. So what is this ghost, really? Well, a 500 error is basically just a signal from DynamoDB saying, hey, I couldn't process that request right this second. The whole service is designed to be self-healing, so the vast majority of the time, these little issues just resolve themselves automatically. You don't have to do a thing.
But when do you act? This is it. This is your clear rule of thumb. This is the signal. If your failure rate, that's your system errors metric in CloudWatch, creeps up over 1% and it stays there for about 15 minutes, well, the ghost isn't just passing through anymore. Now it's time to investigate.
And the good news is, the investigation is pretty straightforward. First things first, check the AWS Service Health dashboard. Is this a bigger AWS issue? If everything looks green there and you're still breaking that 1% rule, then it's time to escalate. Go ahead and open a support case with AWS. And here's a pro tip. Make sure you include the specific request IDs from your logs. That'll help them track down the problem way faster.
All right, gremlin number 1 is down. Let's move on to our next one, the lag. And this one is sneaky. Your average latency might look totally fine in your dashboards, but some of your users are experiencing these frustrating slowdowns. So to really conquer the lag, we've got to look beyond the simple averages and understand what's really happening to our users.
And this is exactly why just looking at one number isn't enough. On one hand, you've got your P50, the median latency. That shows you the typical, everyday experience. But on the other hand, you have P99. That shows the experience of your unluckiest 1% of requests. So if that P99 number is high, it means some users are having a really bad time, even if the average looks great. That's where the lag lives.
So how do you fight back? Well, here is your latency reduction toolkit. Seriously, some of these are simple things like reusing your connections with HTTP Keep Alive, or maybe using eventually consistent reads. Those can make a huge difference. For more critical stuff, you could look into request hedging or even caching with DAX or Elasticache. And hey, if you've got a global user base, global tables literally bring the data closer to them. Every single one of these is a weapon in your arsenal against the lag.
Okay, and now for our final and definitely most complex gremlin, the maze of throttling. It's so easy to just see throttling as a failure, a roadblock, but it's not. It's actually a signal, a diagnostic signal. DynamoDB is trying to tell you something very specific, and if you can learn how to read the map, you can navigate your way out of the maze.
So here's the crucial thing to understand. Not all throttling is created equal. There are really 4 primary reasons you might get throttled. You could have a hot partition. That's where one specific key is getting slammed with traffic. You might have just plain exceeded your provision capacity. Or if you're using on-demand mode, you could be hitting the max you set or even hitting account-level service quotas. Each one of these needs a totally different solution.
So how in the world do you know which path to take in this maze? Well, DynamoDB actually gives you a map. Hidden inside the exception that your application gets, there's this little field called throttling reason. And this is not just some generic error message. No way. It tells you exactly what resource was affected, what operation you were trying to do, and precisely which limit you hit. It is your single most important clue.
So we can turn this whole process into a really simple 4-step framework. Step 1, you analyze that throttling reason in your exception. Step 2, you use that reason to hunt down the related metric in CloudWatch. Step 3, if the reason points to a hot partition, you use a fantastic tool called Contributor Insights to find the exact keys causing all the trouble. And finally, Step 4, you implement the right fix for the specific problem you just diagnosed.
And this right here is basically your cheat sheet for that second step. There's a direct line between the text in that reason and a specific CloudWatch metric. So if the reason mentions key range, you go look for the key range metric. If it says provisioned, you look for the provisioned metric. You get the idea. It turns diagnosis from frustrating guesswork into a repeatable, systematic process.
We have to talk a little more about that sneakiest gremlin of all, the hot partition. This is what happens when your traffic isn't spread out evenly. One internal partition gets completely overwhelmed, even though your table's total capacity looks totally fine. The whole game is to find which specific key is getting all that traffic. And that's exactly what tools like CloudWatch Contributor Insights are for. They will literally point you right to the problem key so you can go fix your access pattern or maybe even your data model.
Okay, so up until now, we've been hunting gremlins after they've already shown up and started causing trouble. But the real goal here, the end game, is operational excellence. We need to shift from being reactive firefighters to being proactive architects, building systems where these gremlins just can't cause chaos in the first place.
And the key to being proactive is all about automated awareness. It's actually a pretty simple flow. You don't need to be staring at dashboards 24/7. Instead, you set up a CloudWatch alarm on your DynamoDB table's most important metrics, like that 1% error rate we talked about, or a big spike in throttled requests. When that alarm goes off, it automatically triggers a notification, maybe through SNS, that pages your on-call engineer. The point is, you find out about the problem long before your users do.
So, let's quickly recap our field guide. When it comes to internal errors, the ghost. Don't panic, but absolutely enforce that 1% rule. For latency, the lag, you have to look beyond the average. P99 is where you'll see the real pain. For throttling, the maze. Remember, that exception is your map. Just follow the throttling reason. And finally, the best defense is a good offense. Build proactive alarms to catch these gremlins early.
And that really brings us to the final, most important thought. Troubleshooting is essential, but it's often just treating a symptom. The real question is about design, about resilience. So you have to ask yourself, is your system built just to run, or is it truly built to last? Because that right there is the key to keeping the gremlins at bay for good. Thanks for joining the hunt today.